So, good evening, ladies and gentlemen. My name is Liz Russell, and I would like to welcome you to this online event on a digital built environment hosted by the information technologists. I will now hand you over to Stuart, who is the chair for this evening.
Thank you, Liz.
Stuart.
So as Liz said, this is hosted by the information technologists. For anybody who's not aware, we are one of the livery companies of the City of London, one of the modern companies as opposed to the historic ones, livery company number 100. And we are the philanthropic arm of the IT industry. So within our livery company, there are several panels or interest groups, and one of which is the IT and Climate Change panel. I'm the chair of that panel and Liz is the secretary. And as part of our panel activities, we arrange webinars and seminars to help educate and inform people about topics related to IT and climate change. So tonight we're looking at the built environment, and particularly with an aspect of the digital aspects or digital twins that can be used with the built environment. We have a couple of fantastic speakers, Dave Phillips and Neil Thompson. So I won't go into too much detail about it. They can introduce themselves.
Yeah, great stuff. Can everyone see the screen okay?
Yes.
Mm-hmm.
Yeah, great stuff. Well, thank you everyone for joining this afternoon. And Stuart, thank you for the introduction. I'm Dave Philp. I'm Chief Value Officer at the Cohesive Group, and also in terms of professional institutions, I'm also chair of the Chartered Institute of Buildings, Innovation and Advisory panel. And as Stuart says, if you can, we've left time for Neil and I to give some questions and answers towards the end of that, if that is okay. Very quickly, my background is I'm a civil engineer to background, and actually Neil and I worked together for many years at Balfour Beatty. I used to be Director of Technical Services. And in 2010, I took a bit of a turnpike and went into this world of digital engineering. And I've been lucky enough to head up quite a few government programs around the world in terms of how we can start to digitize our built environment and try and solve some of the wicked challenges we've got today. So as Liz said, I'm going to be talking about this concept of a built environment. What is it, and how can digital actually help us make sure that we can actually get some degree of flourishing as well? So I hope today that you actually learn something new and something that's going to help you in terms of your own journeys in terms of digitization, and hopefully you can learn from our built environment. So like any good story though, it kind of starts off with a once upon a time. I think at this point in the evening, it's always good to tell a bit of a bedtime story. But actually, when we talk about this journey towards digitization in our sector in the UK, it's something we've been trying for many years. If you went back to 2011, our government was starting of a new government construction strategy and the start of a new parliament. And if you like, when you looked at the government construction client group at that point in time, was a simple hypothesis, and it's always worth bearing, it was hypothesis, that said that government as a client, and one of the key clients in the UK for all our different infrastructure assets, can actually drive significant improvements in cost. And at that point in time, we generally meant capital cost, the cost of designing and building and not the operational cost, but also better value in terms of performance asset and indeed carbon performance. And at that point, we probably meant embedded carbon more in operational through the use of open, shareable asset information. So we're talking about this, it's hard to believe, almost 15 years ago within government. And I'm sure if you took that same hypothesis today, you can maybe just change the word slightly. We're probably in that same trajectory. And we spent 15 years actually proving it works. So if you went back then, our chief construction advisor at the time used these slides. He says, government's got two horses. They're trying to digitize public procurement, government becoming better at buying and using their data, and at the same time trying to improve the dynamics of construction to make it more sustainable. And bear in mind at that point, we were talking about construction and not built environment. We'll come on to that later on. So very simple terms, if you went back to 2010, cash was king, and if cash was king, carbon was queen. So we were trying to ride two horses. And the gentleman you see was Paul Morell, Chief Construction Advisor at the time. You can see that he also said at that point, this requirement for low carbon construction is probably the biggest challenge we had in terms of engineering since Victoria times. But it's important to probably look at two words. It's the biggest change management. Change management. It wasn't just about technology and data, but actually thinking about, especially in terms of change management, people, contracts, in terms of what that looks like. But we started that journey in terms of sector digitization, but also looking how we can do it more altruistically in terms of low carbon as well. At the same time, we had this age-old problem of construction productivity, and digital and better use of data was seen as being a key way to improve upon it. And if you look back, you can see the red line at the bottom. Construction productivity was flatlining. We were not improving it despite all these initiatives. And at the same point, if you look at the silver line up at the top, manufacturing was thriving. And what we looked to try and do back in 2010, 2011 was to try and, as part of the sector digitalization of construction, we're going on the built environment, was to try and pull that red line. So we're thinking about how can we make construction more advanced and start thinking about digitization for advanced manufacture. And we're starting to see much more, if you like, of that convergence between the two pathways. So if you look back, if that was almost 15 years ago, well, where are we in terms of the present day? It was interesting, as I mentioned, we had our Chartered Institute of Building, Data and Technology conference, and as part of that, we've done a lot of baselining across the globe to see where we are within our construction sector, and we're probably at the foothills now of Industry 4.0, so still at the early doors, but we're starting to see much more cyber physical systems connecting, if you like, the physical asset with the virtual asset, especially through sensor technologies and networks to bring them together. But again, we're still at the foothills. But let's compare the challenges we had back in 2010, 2011 today. Have they changed? Well, I think when we talk about carbon now, it's much more in terms of a wider, much more wicked challenge we've got. It's more about climate resilience, mitigation and adaptation, including circular economy for assets. At the same time, we've had tragedies around the world, especially in terms of Grenfell, that's looked at, we have to improve the safety, reliability and assurance of our assets. The reality is we have an existing aging infrastructure, especially here in the UK, it's historic. We need to be able to understand it better, monitor it better, and actually be able to improve the performance of our assets. At the same time, we're trying to improve whole life cost and performance and maximize efficiency and move away from the traditional labor intensive ways to much more advanced manufacture. The image you're seeing it's the built environment sustainable transformation. It used to be the Construction Scotland Innovation Centre just outside Glasgow, but you can start to see that 6-axis robot now looking at ways of digitizing how we do it using advanced manufacture, but also looking at the same time and trying to do it in the most sustainable way. And that's not just in terms of new build, but also in terms of retrofit as well. And we've got the challenge now that, we've got lots more data compared to 2010, but it's all disparate. How do we better connect it? How do we get context? How do we ensure interoperability as a means of being able to answer these challenges we've got today? But we mentioned right at the very beginning, this concept now of construction is part of a built environment, and our vision, and I'm sure it's the same round about the globe, it's to create a modern and thriving built environment. I think it's fair to say we've created a somewhat amazing and complex machine on which we wholly depend. And without it, our lives would be immeasurably worse. And the reality is, when we talk about our built environment, society would not survive without it. And that machine is our infrastructure, and our infrastructure is our built environment. The reality, and I hope you can see that through the diagram, but our infrastructure is inextricably linked across social, economic infrastructure, and our natural environment. You can see the 3 layers. If you look at the top, think about the economic infrastructure you rely upon every day, from transportation networks, energy networks that get us to and from, might be from work or to hospitals, social infrastructure in terms of the hospitals, the schools that educate us, and indeed our natural environment as well in terms of biodiversity or flora and fauna that are at. And now we're seeing a convergence between these interconnections and interdependencies between economic and social infrastructure and the natural environment. And if you think about the interdependencies between these 3 layers, it includes, if you like, flood alleviation, recreation, resources, waste disposal. Ensuring resilience and sustainability across these key areas is key. So you can think about, if we bring these 3 areas, if you like, of infrastructure together, you start to see we create an interconnected built environment. So it's a sum of all the infrastructure that we thrive and need to help us move forward. So how do we think about a digital built environment within there? Well, obviously we've got our physical infrastructure. You can see at the bottom, but we are now trying to, if you like, create, if you like, that virtualization. And we can start to think about connecting through sensory networks and other ways, including data scraping, of trying to create, and this is where we get the concept of a digital twin, that physical and cyber connection, that if we get it right between the physical and digital worlds, we can start to make smart interventions because we now have insights about our assets, how they're performing, and that means we can get better outcomes. So creating a line of sight between our assets, how they're performing, and the outcomes that are realised. So start to think about our infrastructure and how we can digitize it in the context of a built environment. But it's much more in technologies. It's about the data, it's about the processes. So when we think about digital twinning, it's not just about twinning and creating a nice model, we'll come on to this, but it's also looking at the different processes that surround it, and indeed the human computer interventions as well. But what we're trying to do is link the physical and digital environments. And by doing this, we can help infrastructure operators to make better informed decisions that are going to lead to more improved and sustainable outcomes. At the same time, I think we're lucky enough in terms of the shift from construction to a built environment. This is an image, if you like, of a modern built environment. And this comes from our infrastructure performance roadmap in the UK. It's a journey towards 2030. But you can see what it's trying to do. You can see right up at the very top, we've got United Nations Sustainability Goals, which I'm sure members and visitors here know well. But often there's such a big, high-level ethereal sort of thing. People think, oh, actually, how do we actually do with our daily activities? And how does our built environment actually fit into this? So you can see down at the bottom, we mentioned the built environment, including the natural environment. Well, we carry out activities there in terms of modification of our assets, might be retrofit, creating new infrastructure, high-speed 2, new hospitals, or trying to optimize its performance. Now, what we can start to do now is think about the data, and through digital twinning, other digital interventions, that data is going to give us insights at a system level, a network level, an asset level, or a project level. We can start to make well-informed and more sustainable decisions. And the more we can integrate data about how our assets are performing, and more importantly, the services that perform. When we create a bit of infrastructure, it's not just a case of design it, build it. We operate them. It's a service provision of these assets, especially in terms of operational carbon. We need to know much, much better as well. And once we can get better connected data, especially at a national level, it links across to these high-level ESG outcomes. So it creates a line of sight, both top-down and bottom-up, between the bits of data on a daily basis and these high-level goals that we're trying to do. However, probably our biggest challenge we've got is, especially within the UK, that a lot of our infrastructure is quite historic. It's been there for many years, and we've had trigger events, as we mentioned, such as, if you like, the Grenfell fire, but also up in Scotland also, with projects such as Oxgangs Primary School, where we've had collapses of walls, which meant unavailability of data there. And what it highlighted was there was a lack of availability of searchable, indexable, computer-readable information. And making searching difficult, it's often a manual process. You have a consequential event that can lead to tragic situations such as Grenfell or the falling masonry. They've highlighted the need for centralised and indexed data about our built infrastructure. And you can see within there, I think this is a real interesting fact, you can see these orange boxes. This is from the Centre for Smart Infrastructure at Cambridge University. It highlighted that 99.5% of our infrastructure already exists. So we create new projects every year. It's only adding 0.5% of the value to existing infrastructure. So being able to understand existing infrastructure and get more out from it, our networks, our campuses, means we can get better availability, capacity, and resilience. So it's not just about creating digital twins of the new assets, but how do we digitize the assets we already got? One of the early adopters to try and achieve this is our National Health Service in Scotland. It's one of the biggest asset owners. It's made up of 21 health boards, and they are quite unique because they actually operate all their assets themselves in-house. And they wanted to get a better understanding and digitize their assets, and they called it the digital estate. You can see with here a geospatial map Hopefully everybody recognises it. It is Scotland, just for those that maybe haven't seen it before. But yeah, this is a bit of the north within there. This is the north, just to say. But you can see it's a geospatial map that you can search across all your different help boards. You can drive down into a particular site. You can see within there, this is coming to Glasgow Royal Infirmary. Within a board that's in Greater Glasgow and Clyde, you can start to see all the information that's now coming up. But we're searching at an enterprise level. We can get down into a block level. You can see all now the individual blocks, but we're starting to pool and integrate data sets together, geographic information, along with other asset information within there as well, including 3D models. And what allows us to do is to create indexable search. It might include all the as-built information, certificates, or operation and maintenance, and also all the residual assets. But anyone, a help board, can now search across all these help boards and find information. What's the asset made of? What's its safety regime? From there, it's linked across, if you like, indoor mapping. You can actually see a bit like indoor Google Street Map. You can walk through it, make better decisions. You can click on an asset and find out more and more about it. So what does this all mean? Well, what we're seeing is, we're seeing a real shift towards a digital built environment. Digital technology and data, but also new data science skills are changing how we build, maintain and use critical infrastructure. Concepts such as information management, which the UK government is strong in mandating, building information model, geographical information are already transforming. But these were very siloed data sets. We're now seeing a real conversion, and the conversion of digital twins, artificial intelligence, but also serious gaming capabilities as well. On the right-hand side, you can see some examples. The one at the top is a digital twin at a city level, which is not just about sensors, but it's about scraping data as well. You can see the one below on the right is a dam. You can see all the green sensor points. It's monitoring its performance, checking for any cracking or spalling. To the left of that is it's using serious gaming to look at a fusion reactor as to how that could perform, campus twinning, and the bottom right is looking at autonomous plant for construction. Now, these are all elements, if you like, of this digital built environment. At the same time, we're also looking at not just above ground assets, but Ordnance Survey is now looking at operation of a national underground asset register. So creation of our assets both above and above ground. But it's that key of asset registry, and just knowing where all our assets are and what they're made of is increasingly, really key to, if you like, improving safety, productivity, and operation. And I think above all for me, the big thing is it enables, think about the built environment, enables users to make better use of the infrastructure we already have. With the Chartered Institute of Building as well, which both Neil and I are on, I've been chairing a group looking at artificial intelligence in the built environment. We mentioned Industry 4.0. These are the themes that we saw that they were making up within construction. I'm not going to go into it from there, but you can see some of the key ones: digital twinning, sensory networks, analytics, robotics, human-machine intervention, all at different levels of maturity within our built environment. But some of the things we did see is, when we think about the data flow in terms of an infrastructure project, the design, build, and even the handover is very small. It's a blink of an eye. It can be something that's done in maybe 2-3 years, but the in-use, the operate and maintain, it can be 10, 20, 30, hundreds of years. So it's thinking about the data over its entire life cycle, its integrity. So data governance, data quality are hugely important. And at the same time, the UK has been looking at value-based decisions. So imagine you're building a new scheme. How do you make a value-based decision, dropping data that can check, what does it mean in terms of biodiversity, social value, whole life cycle costs? So we're value-based decisions. And of course, it needs data. Looking at how we can get better adoptability of digital within there as well, but also thinking from people, organizational change management, how we change behaviors and culture of how people consume and how they use data, but also in terms of, as we mentioned, not just at asset level, but systems on systems and considering our built environment. And when we do this, we can start to exchange data. It might be a bit small within there, but we can start to take the data and make smart decisions round about maybe carbon performance, as you can see within the box on the right-hand side. It's just an example, if you like, of data exchanges to give insight and look at improvement. And we're now starting to see, if you like, the move into digital twinning. Obviously, we give a concept, but it does have different levels, if you like, of temporal scales, scalability from individual assets. Now, the UK is in the journey to exploring a national digital twin. But you can see the different levels of moving from a descriptive twin, a reliable digital representation, to informative, where we are starting to pull sensor data within there, looking at the operation performance, to start to think of using AI and predictive twins, where we can start to really predict and simulate future what-if scenarios. And then we can combine data across organizations and a tons, but we're probably as an industry, we're somewhere between 1 and 2, that descriptive to informative twins within there. But again, we're starting to think from a data point of view about master data management, data security, data governance at the height of it. And we've also seen demonstrator projects in the UK. If you haven't seen this, it's worth putting into Google. It's called the Credo, which is the Climate Resilience Demonstrator. We looked at combining, if you like, the combined twin of sharing data across organizations to be able to make, if you like, joined up decisions around about infrastructure resilience. And that was led by, again, the University of Cambridge. Just as I finish up then, this is an example, if you like, we're seeing, if you like, hopefully this will run of AI within the built environment. You can see within there, you can see the traffic lights. This is using AI in terms of roadway insights. It's using crowdsourced image data to collect and combine, if you like, machine learning models. It's trying to inventory, if you like, everything that's out on a road network. It's crowdsourced, which I think is pretty cool. But then we can start to analyze asset conditions, prioritize maintenance. We can find out if white lining is perhaps deteriorating from there as well. So we can start to create accurate and consistent inventories at scale. And with AI, you can start to create automated reports for people to go out and actually do some work. So I'm just going to finish up before we hand over to Neil, saying, well, what does this all mean? So number one, we need to get the basics right. It doesn't matter if it's building information model, geospatial, digital twinning, AI, they all need to be built on quality data. So data governance, ISO 8000, and all the subset are very, very important to us in the built environment as well. It's got to be in terms of digital, it's got to be aligned with business outcomes and use cases. It shouldn't have a disconnect. And we should be using information management best practice. Again, there's lots of good standards out there in the world of built environment. We're very ISO 19650. But as we mentioned, it's not just about data and technology. We need to weave in people and culture, because it's going to help us get better collaboration. We've got to be appropriate and proportionate in terms of the security of the data around about it. We also use this term soft landings to make sure that data can flow seamlessly between, if you like, the construction world and operational. And actually we start with the end in mind, understanding what those operating assets are going to use data for as well. We also need to consider information curation, because we know it can fall into disrepair. And then we've got to treat our information as the same strategic value and with the same love and keeping it evergreen as our physical assets. And we do need to consider more and more integration architecture and information management frameworks. But data should empower everyone, especially the end users. And it's something that's got to be evolve over time. So it's a bit of a canter for me, but I hope a couple of things. I hope you take away a better understanding of actually, we've got this built environment that is actually so important what we do. We've got a great opportunity for digital to help improve in terms of climate resilience, decarbonisation, and it's all about good quality data. It doesn't matter what, I'm sure it's the same within your other working groups as well. Data governance and getting data right is right at the heart of what we do. So at that point, I shall stop here, and you can do the segue to Neil. So Neil, it's like...
Okay, so hello everyone, I'm Neil Thompson. I'm a technical director at Atkins Realis. I have a checkered past in the construction industry. I've worked as an engineer. I've worked as an economist. So when I say economist, I mean sort of designing teams and contractual arrangements, and also have applied technology in lots of different contexts. Current role is I'm part of a JV team of a major piece of critical national infrastructure in the defence sector, and that's about as much as I can say about that. But I also just about to start a role as an advisor at the Department of Science, Innovation and Technology as part of the Regulation Innovation Office. So it's a shame that nobody clicked regulation, but in terms of the UK government, they're going to place investment into modernizing regulation and using information and data to do so. So I won't dwell too much on much more of my introduction, but I've played a role in both setting up IT systems, but also as an engineer and trying to use IT systems in muddy fields and design offices and what have you. So I have a broad experience here. So I was just going to provide some background. So for me, for me, data does not equal information. They're very different things. Data is in the world of IT systems and IT infrastructure. Information is in the world of how people do work on top of those systems. And what I systematically see in the work that I do is people get those two worlds mixed up, and within their strategies or within documentation or how they do things, tend to use information and data as something that is synonymous, but they are not the same thing. And I to illustrate that point, and don't worry, we're not going to have a music lesson here for anyone that doesn't understand music notation, but it makes an interesting point. Data in terms of music notation on its own doesn't make any sense to anyone. Same with words. Alphabet soup on the screen doesn't mean anything to anyone. Information is how we put all these bits of data together to make it more useful. But you can do two things. You can either, with music notation, you can put it into a set of standards of how you set out that information to make it more consumable, or you can lay all the notes out next to each other and just play them as you go along. It sort of depends on your level of skill. Now, how that turns into sort of knowledge and wisdom is quite interesting from a music perspective, because if you fed music notation into a machine and ask it to play it, think of your most favorite song and ask a machine to play it perfect note for note, it will sound strange. If you play music perfectly, it doesn't sound right. The thing that makes music sound the way it does is generally humans play it, and those little human touches and the notation, the human annotation on top of this notation here is what gives it that feel and that human aspect of how we do our work on top of digital systems is a very important dynamic, and that will never change. No matter how much technology we invent and how much technology we implement, that human interface will always be critical. So for the digital built environment, we're sort of seen as a laggard because we're sort of, I think, is a misperception. We tend to think, oh, the built environment sector or the construction sector isn't innovative, but I would like to challenge that, and I will construct my argument in the next couple of slides. So let's look at other industries where, sorry, not other industries first, economics of digital first. So interestingly, from other sectors that we'll cover in a sec, the economics of digital are important here. So the cost of compute, the cost of storage, and the cost of connecting all those things together is essentially a point in which it's given away for free. If you think of a lot of the services that we use in digital infrastructure space, you can access them and use them for free. And into sort of more modern economics of sort of the cost of prediction and utilizing infrastructure, you can access ChatGPT, which is an AI assistant tool, for free. And use quite a high level of that capability. And that's having a profound impact on how we work today. Now, the interesting thing to throw the construction context into this is the cost of automation from a physical perspective. So robotics is the cost of labor versus a robot is reaching an inflection point. So when we add all these things together, actually my point here is, it's not that the construction industry has been behind, it's that technology has only been available in over the past sort of 5 years where we can actually utilize the scales. David showed the National Underground Asset Register. We've only reached a point where we can actually hold that level of data in a system and connect to it through the internet. 10 years ago, we just wouldn't have been able to do that. So that's important context. going to run through some other industries first, because I think it's important for us to understand that lots of industries have been on this journey already, and it's more about us learning from those and taking inspiration from them. So agriculture, a place where 90% of the world's population worked in agriculture. Today it's in sort of 2 or 3%, but productivity is 100 to 150% more. And those worlds look completely different. So 90% of people standing in fields to nobody standing in a field, but the technicality of the skills required to achieve that are completely different. The skills in the agriculture sector in 1790 will look completely different to it is today. Autonomous machines, and the maintenance of those, and the design and what have you is completely different. Let's have a look at communication technology. It's almost the other way around. Instead of it being 90% of the population and tending towards fewer people, it's the other way around with information technologies. It started off with few to few. We've got a Morse code operator during previous wars, and that was a one-to-one relationship. In the middle, if we think about sort of the noughties into the tens, computing and technology is ubiquitous. This is a picture of some people working in Palo Alto, and you could probably operate a multi-billion-pound startup in Silicon Valley in a living room, through to today where people are not even required. There's an example here from the I don't know if you're aware, but there was a deep fake incident with Arup where the CFO was tricked into handing over $25 million. This bottom graphic here, none of the people on that slide exist. They're all generated. So there's a profound future for information technology going forward. We've connected everyone, and what does it mean when we can the machines can sort of replicate us as well? So that's an interesting conundrum. Music industry, this is my last example, but in the bottom left hand corner here, that is the Neve recording desk. It cost about $1.4 million to produce the Fleetwood Mac Rumours album back in the 70s, which is in stark contrast to the image in the middle. The image in the middle is that is Billie Eilish's brother. Billie Eilish is a huge pop star. She put her music out on a free platform called SoundCloud back in 2015. She was 14 years old, and she's gone multi-platinum with that technology. So that in that room, Billie Eilish's brothers, that technology probably adds up to about maybe $15,000 worth of technology, and created a multi-platinum selling, multi-million pound selling album compared to what that was like back in 1973. Now we're in a world where we could all go and get a song created on the fly using AI for free. So what cost multi-million pounds back then is now essentially free today, which has a profound impact in terms of swap the musician with an engineer. What does that mean in our context? And this is important from a construction procurement perspective, because this is search sentiment over time just for consumer products. When we first started to buy things on the internet, search sentiment was more around, where can I find the cheapest thing? What has slowly happened over time is that sentiment shifted from, I don't just want the cheapest thing, because if you buy the cheapest thing, you get what you got. We've learned over time that we actually want the best thing. We want the best performing thing for the money that we have. And technology has served more sort of consumer, especially with sort of internet technology. We've been able to print media, music industry, entertainment industry, and consumer products has been enabled by the internet. And I think we've only reached a point where it's been credible for this technology to serve the procurement of more complex outcomes. Buying something cheap from the internet to like an umbrella is nothing like buying a nuclear power plant. But that technology that's enabled us to buy me the most best performing umbrella is going to support us to enable infrastructure clients to buy don't ask the industry what's the cheapest, because it still technically does that today. It goes out and finds the cheapest. Go and find me 3 quotes and we'll take the cheapest one. It still does that today. But with technology, we will enable clients to buy best performance. We've done it with consumer technology. We will do it for more enterprise level things. So what does that mean for us? And in my context and in my day job, first of all, there's loads of big questions. One of the big questions is about the role of IT and the role of digital engineering. They need to come together. More of that in a second. But when we start out, we need to bring the world of information technology, data management and governance, and the information management and digital engineering worlds into a more integrated space to answer these questions. They can't be answered outside of this, and maybe there's some of these questions on this screen that we can discuss in Q&A. But when I sit down with my teams, these are the sort of questions that we ask, and we have to ask a far more broader set of stakeholders these questions these days. It's not just about an IT department, it's not just about an engineering delivery organization, it's in them together. In terms of the team and the team that I've designed and put together for my context, sorry I can't talk too much about the project, but this is the first time I've managed to pull together both essentially an enterprise systems team of approximately 20 people that deliver all of the underlying infrastructure. Then adjacent to that, or shall I say on top of that, the people that use that technology are a digital engineering and delivery team that does all the digital rehearsal, all the things that David was talking about in terms of getting people to make decisions around simulations, 3D models, and where they conduct the information management about the decisions that we're making about this national critical infrastructure. And then, on top of that, this world does not stand still. Look at how much change has happened in those previous industries. It's going to happen really quickly for this one. So it's making sure that we have a continuous improvement mechanism on top of that. The program that we're on is a 15-year program. Well, it's much longer than that as in other contexts, but in the current context, it's 15 years. And I mean, just think of, just going to go back a slide. The space between 2015 and today, where we've got AI technology essentially generating music on the fly, is well within the time limits of this. So we have to have that continuous improvement mechanism, and within that, we have to think about how we're going to build a digital twin, for example. And this is not supposed to build, so I'm just going to flick through. A slightly different adjacent context is this is a reference architecture of how you build a digital twin for a nuclear fusion plant. Now, the important thing to understand here is that, and I guess to use the internet as an analogy, there's a difference between the infrastructure that connects a load of computers together to enable the internet and the browser that sits on top of that to enable you to navigate it. The important thing is to separate those things out. So there's a load of stuff. So for example, in here, the layer at the top of this, what I tend to call the twin interface, is the browser. We have to go and find information and make decisions about all the stuff that sits underneath, and all the stuff that sits underneath that in engineering context is our internet. We have to, there's a fusion reactor and all the things that happen in that operational context with this side. It's on the right hand side of this is the building and its surrounding infrastructure, and we have to build all this technology infrastructure to ask a simple question about how many bolts do we need in this. You need all of that infrastructure to answer that question. Sounds like a trivial question, but actually to answer it, there's a load of infrastructure that comes together to do that. I think this is more thought and willing to talk about this more in Q&A, but just to give you an example of these are the kind, it's a complicated problem. This is all the things you need to plumb to ask relatively simple questions. My final piece here, considering we're talking about sort of climate change and what have you, is just because we can deploy technology doesn't mean we should. My worry and my existential worry is two sides of the same environmental coin. So on the left hand side of the coin is, and pun intended, Bitcoin. This is not even including AI. Just Bitcoin alone is consuming enough energy the size of a nation. AI is much bigger than that. I couldn't do enough research in time to get you a credible number, but these things are energy intensive, and it's only going to get worse. It's not going to get any better. Our demand for energy consumption is only going to exponentially grow. And it's something that we need to be mindful of. I think as IT professionals or professionals in the built environment space, to enable digital outcomes of this, we have to be custodians of that. The other side of that coin is, and the reason why I take sort of the death risk factor of the world, is air pollution and outdoor air pollution is, 40% of that is the built environment. So we've got a growing concern of how the energy intensity of the technology that we're going to use to make a built environment getting more intense, but then the actual outcome of the infrastructure that we build still pollutes and enables pollution. We've done a very good job of building roads and putting cars on those roads, but the unintended consequence is the pollution output of that. So I think my plea here is, yes, technology is going to play a very important role for the future, but we have to do it in a way that is sustainable, because at this moment in time, these, on both sides of this coin, the ecological impact of the built environment and its technology is going to be, at this time, detrimental to the future sort of outcomes of our well-being and health. And on that doomy note, I think we're over to questions.